In this question, we're given four different functions here on the right and asked to find or evaluate several function values, as well as determine the inputs or x given the function value. These first two questions deal with function f of x graphed here in blue. To evaluate f of 4, we want to find the function value or output when the input is 4. Because we have a function of x, we can also think of this as determining the y-coordinate when the x-coordinate is 4. So looking at the graph, notice how here's where x equals 4. And notice how the y-coordinate or function value at this point is positive 3. Again, this is the point 4, 3, which means f of 4 equals 3. Next, we're asked to determine x, or the input, when f of x, the function value, is negative 3. So the function value f of x equals negative 3 is the y-coordinate. So now we're looking for the x-coordinate when y equals negative 3. So again, analyzing the function, here's where y equals negative 3. And notice how the input would have to be negative 2 at this point. The coordinates of this point are negative 2, negative 3. When f of x, or the function value, is negative 3, the input, or x, is negative 2. So when we're given f of x equals negative 3, this negative 3 is the function value, the output, or the y-coordinate. The next two questions deal with function g, which is given here as a set of ordered pairs. To evaluate g of 54, again we're looking for the function value or output when the input is 54. Again, we have a function of x, so we're looking for an x-coordinate of 54, which is here. And notice how the function value or output, which is also the y-coordinate, is 70. So g of 54 equals 70. And now we want to determine x when g of x equals 62. Again, here 62 is the output or function value, which should be the y-coordinate. So now we're looking for a y-coordinate of 62, which is here. Notice how when the function value is 62, the input, or x, is 56. So if g of x equals 62, x must be 56. The next two questions deal with function h, where h of x equals negative 7x minus 3. So to evaluate h of 14, again we're looking for the output or function value when the input, or x, equals 14. Let's go ahead and find this function value on the next slide. So to find h of 14, we substitute 14 for x. That would be negative 7 times 14 minus 3, which is equal to negative 98 minus 3, which equals negative 101. So h of 14 equals negative 101. And the second part of this question asks us to find the x value, or input, when h of x, the output, equals 74. Which means now we'll substitute 74 for h of x and solve for x. So we want to solve the equation 74 equals negative 7x minus 3. We have a basic two-step equation here, so we'll add 3 to both sides. So we have 77 equals negative 7x, and of course this is 0, so we divide both sides by negative 7. We have negative 11 equals x, so of course x equals negative 11. Let's go ahead and record this on the previous slide. We had negative 101 here, and we had negative 11 here. And now for the last two questions, we're working with function p of t. So now notice how the input is t, and the output, or function value, is p of t. So to evaluate p of 54, we're looking for the function value when the input, or t value, is 54. Notice t equals 54 here. When t equals 54, the output, or function value, is 20. And therefore p of 54 equals 20. And then finally, we want to determine t, the input, when p of t, the output, equals 17. So now we're looking for an output, or function value, of 17, which notice occurs here. When the function value, or p of t, equals 17, notice how the input, or t, equals 56. And therefore, when p of t equals 17, t equals 56. I hope you found these examples helpful.